So we've had a look at that approach of the static and the ruled terrain, and we've seen what they give us. So let's have a look at sort of importing legacy data and how we can deal with that legacy data. And really what we're talking about with legacy data is you're probably going to be going down the static rule route. So you'll have an external file that you're monitoring, that you've imported and maintaining a link to. I like to think of this as pre-cooked surface. The legacy product is still in control of that surface. That's where the recipe is coming together for that terrain surface and making the surface, and you're just bringing in the resultant of it. So what you need to think about really is, do you want to edit this surface in OpenRoads? Because the rule is actually maintaining it back in the legacy file. So if that is the case, if you do want to edit it, you may want to consider other means of getting that terrain in. The other thing is that if you're just importing that terrain surface and it's got linear features in it, break lines, you're not going to be able to extract those to target those in typical practices with corridors. So again, you may need to consider another method, be it just display the graphics and actually have the graphics. And again, if you're displaying the graphics, you could actually use a different rule engine, which is the graphical filter to import that as a terrain. So you've really got a couple of methods with regards to legacy data and how you manage that. There is an option to import the features, and so those breakline features that are stored in the legacy terrains, you can extract those and get graphics from those. But what you have to consider when you do that is the implication again, because you're generating graphics that are individually ruled. So the elements are getting ruled, becoming a dynamic rule there. So again, you have to consider when you're doing that, it brings in the graphics, it featureizes, and it has to build rules associated with that. So it's potentially slow in comparison with just using other methods of displaying the model and then using a graphical filter to rule it. But there are cases where you might want to use that import features option.
When we're dealing with legacy file formats from any of the legacy file formats of Inroads, Geopack or MX, we're essentially dealing with a pre-cooked surface. It's ready formed, ready made. So we can import here the terrain, it's ready formed. I'll just assign a feature definition, existing triangles, and import. Obviously I have reprojection capability and so on. So this terrain surface is now ready to use. The disadvantage to this sometimes though is if I turn the triangles off, although there are the linear features and spots and break lines and so on stored within the DTM, they are embedded within the DTM, but they're not accessible to target and actually utilize. So what you might want to consider, instead of just doing a straight import of the DTM and utilizing it, is what do you actually need from this DTM? Is there a need to see the linear lines that make up this surface, and is there a way to get those? Invariably there is, because within the legacy file formats we can display graphics, and then we could utilize the create terrain by graphical filter. But if we just want to import the features and potentially target them, we have another option available to us as well within the terrain tools. So what I'll do is, in this particular file, I'll create myself a new model called 3D Breaks. I can reference this through into the main file as well if I need to. And I'm going to go back into the legacy file format now, and instead of picking up on the terrain only, I'm just going to look at the features. I'm going to ignore the spot levels, and I'm just going to import the graphical features. And where those features match the active style and symbology, they'll be featurized and drawn in the correct style and symbology. So if I start this process importing and then come back to it after it's completed the import. So now we have a display representation that we can utilize to target graphics, deal with picking, point controls and things like that. So obviously the only thing that we now need to do is go back into the default model, and obviously we can now reference this through into this model.
So really what we're looking at here is when we're dealing with legacy data, again, it's all about the size and what you actually need from the data. So just sort of think about that and consider other methods, because there may be simpler ways of doing things, and look at the rules and see what they bring to the party and decide which rule is best for the data that you're working on. Certainly for large amounts of data, I would always consider doing a graphical display and using the graphical filters to create the terrain from that. But for smaller features, you can import the features just as we've shown there. That is perfectly fine for smaller amounts of data, as it writes those in and featureizes that civil information for you. So just a couple of methods for dealing with legacy data. So I keep talking about graphical filters, and what is it? Well, let's take a look at graphical data and how we can actually utilize that and what we need to consider when we're dealing with this. So basically a graphical filter allows us to create a static rule. It can also be dynamic if we need it to. There is an option to link to the terrain feature itself, and so we can get certain features to be dynamic at the same time. So a graphical filter can be both static and dynamic. Sounds complicated, but there's only certain features that you might want to pick up on, and as a general rule it's going to be static. But really it's targeting bulk import, large amounts of graphical data. They don't all have to be in the same file, they can be referenced through. So again, consider the structure of your DGN and building that up into a referenced file that you can then create your terrain from.
Graphical filters provide us with a powerful means of controlling the bulk import of data. It allows us to build a static rule that we can then maintain and run separately. We can do this by picking on a series of attribution, selecting from the graphics and building up new filters, and distributing these via DGN libraries. We can then filter out and take out various attribution that we don't actually need and just simplify the parameters as we need. Once we've built up a set, we can then build up a group that includes lots of filters that will ultimately include all of the data within the DGN. So these can be driven as standards distributed by DGN libraries. Once we've set up our standards and in place, we can select the filter, either an individual filter or a filter group. So a few of the advantages of graphical filters. One, if we get the filter group wrong, in this instance the buildings have been put in as break lines and we need them as voids, we can add those as voids. Finish. And then we can simply refresh the terrain rule and update from source, and now the buildings have all been added in as voids. Other things that we can deal with, we can see here that we have some invalid elevation data. So we need to filter this out and exclude the points that fall within that range. So again, we can do this within the filter group. And again, I'm going to pick on the buildings and edit the filter, and in this instance give an elevation that is less than 0. And then refresh the rule to pick up on that change in the individual filter. So it's a very efficient way of dealing with bulk data and quickly refreshing and updating and dealing with small changes within the graphics. An additional feature that can be built in is the ability to deal with linking of features. So we can link the features actually into the terrain. And what this means is those features that fall within that category now become dynamically ruled. So although we have a static rule to the graphics, we have individually ruled that when we make changes onto an element, it's now tracking and automatically updating the terrain in relation to that particular feature. So graphical features, the graphical filter provides us with a means of blending both static and dynamic rules.
So graphical filters, very powerful tool, and they really work with bulk data and repetitive imports. So if you've got CAD standards defined, being supplied data in a CAD format, this is a good way of dealing with it. Set up a DGN library with the appropriate CAD standards, and then you have a direct import that's essentially a very quick process. And those can be distributed by DGN library and distributed in your workspace. With the Select Series 3 Maintenance Release 2, we have got some additional capability coming in terms of dealing with civil feature definitions. This is particularly important when we start dealing with subsurface pavement layers, corridors and civil cells, when we start looking at machine control surfaces. We've also added in the additional capability to be specific on the exclusion of certain elevations, so that you can get rid of null points or erroneous shots within the data itself.